Our class today will look at probability, specifically what we call the discrete random variables. So whenever we're dealing with discrete random variables, a discrete random variable is simply a variable that can take any countable numbers of distinct values. Typically, when we are using an experiment, we usually include numbers of heads. For instance, the heads of a coin, the number of people in a class, the number of defective items. Those are discrete random variables. So these discrete random variables specifically are not integers. We have what we call continuous random variables, where we have fractions. Discrete random variables, we deal with whole numbers, 1, 2, 3, 4. Discrete, there are no fractions in this case. Okay, so there are several properties that we look at when you're dealing with discrete random variables. So a number of them are as listed above. So they follow what we call a probability mass function. Discrete random variables follow a probability mass function, which gives you the possibility of each value of the outcome. It is denoted by Px is equal to x, where x is the random numbers of specific, then you're given the probabilities associated. Now, this is the simplest probability distribution, I must confess. So I'll give you a typical example following what we discussed yesterday. Probability must always range between 0 and 1. So you cannot get anything more than 1. You cannot get anything that is negative. So let's look at this typical example where you're given the probability of x, or the random variables are given, the values of x are given as 2, 4, 6. And the probabilities here are being given as 0.3, 0.2, and 0.5. So this is a probability, a discrete random variable, and we'll be asked to calculate three things. Number one, they'll be asking us to find our mean or expected value. It's also called the expectation. Number two, we'll be asked to calculate the variance. And number three, you'll be asked to calculate the standard deviation. And maybe the probability of x is greater than 3. So this discrete random variable, the easiest way to calculating it is to come up with a table that I'll show you. So we have the values of x that have been given, which is 2, 4, 6. And we've been given the associated probabilities, and these probabilities must add up to 1. So 0.3, 0.2, and 0.5. When we add them up, are we getting 1? Yes. All right. Then what follows up is now we're calculating the expectation, which is also called the mean, which is also called the expected value. So how do we calculate this? We multiply the value of x and the probability. So this is probability times the value of x. So 2 times 0.6, 2 times 0.3 is 0.6. 2 times 0.4 times 0.2 is 0.8. 6 times 0.5 is 3.0. So when you total this up, here we have 14. Here we have F4. So this is how we find the value of the mean. As simple as this. So the mu, which is a mean, and then we put letter E and an X there. If you want to show the working, you can just say 2 times the probability, 0.3 plus 4 times 0.2 plus 6 times 0.5. This only gives you 3 marks. So the mean here is 4.4. Then how do we find the variance? We first square the values of X here. When we square the values of X here, we have 4. 4 squared, we have 16. 6 squared, we have 36. Then we multiply these squares to the probabilities. So 4 times 0.3, we have 1.2. 16 times 0.2, we have 3.2. And 0.5 times 36, we have 18.0. So you total up this column. What do we get? So we're going to add up here. We get 22.4. So this is not the variance, but when we subtract the mean from the summation of X squared, that is what we call the variance. So the variance of X is simply summation of X squared times the respective probability minus the mean we found to the power 2. So this is 22.4 minus 4.4 squared. So what do we get? Somebody to calculate. What are we getting? Let's calculate quickly so we move fast.
Three point zero four.
3.04. Okay. 3.04. So that is what we call our variance. So 3.04. To get the standard deviation, we square root the variance. So what's the square root of 3.04? Standard deviation is simply the square root of the variance. When we square root the variance, 3.04, what do we get?
1.7444.
1.744. So this is how we find our variance. So a quick recap, we're given the values of X and their respective probabilities. And we are asked to calculate the mean. We're asked to calculate the variance, and we're asked to calculate the standard deviation. So in this regard, we calculated the mean by multiplying the values of X and the probabilities. The sum total is directly the mean. Okay. Then we're asked to calculate the variance, so we square the values of X in here, and multiplied by the respective probabilities. So the total that we got was 22.4, and we subtract the square of the mean to get our variance. So in this case, the variance is specifically the mean squared minus summation of x, the power 2. Then the last part we're being asked here is to calculate the probability of x is greater than what? 3. So which values here are greater than 3? If I may ask, which values are greater than 3? In terms of x, which values of x are greater than 3?
1, 6.
Good. So the probabilities x is greater than 3. In that vein, we have x is equal to 4 and x is equal to what? 6. So what are the probabilities of 4? What are the probabilities of 6? If I said probability is less than 3, there's only a 2 there. X is more than 3, there's 4 and 6. The probability of 4 is 0.2. The probability of 6 is 0.5. So in this case, we're going to put 0.2 here plus 0.5. The total probability we're going to have is 0.7. All right. So I want to make it difficult for you to fail than to pass unless you just want to fail on your own. So anyone behind so far? Let's try another example. Suppose we're given the values of x. 1, 2, 3, 4, 5. And the probabilities of x 0.2, 0.1, 0.25, 0.15, and 0.3. Quickly, can somebody help us? How do we find the mean? What do we do? The mean. Find the mean. Find the variance. Find the standard deviation. And find the probability of x is greater than or equal to 3. So let's start. Who wants to help us with the mean? How do you find the mean?
Apply the values of x and their probabilities.
The values of x and their respective probabilities, correct? So just multiply. So here we have 0.2, 0.1, 0.25, 0.15, and 0.3. So to multiply them, first ensure that the total for the probability is equal to 1. If they are not, there's a problem somewhere. Then multiply the probability of x times the x values themselves. So 0.2, 0.2. This is 0.75, 0.6. And finally, what do we get? 1.5. So the total here is actually our mean. Who can quickly total up for us?
Three point two five.
3.25.
0.25, correct? So this is our mean. So our mu, our expected value, is 3.25. Lady, this time, how do you find the variance? We square the values of x first. right? You can bring back their probabilities here if you like. You multiply the values of x squared with their respective probabilities. So 1 squared, that is 1, 4, 9, 16, and 25. And here the probabilities, just bring them back here if you want. Again, 0.1, 0.25, 0.15, and what? 0.3. So let's multiply this by that, 0.2. This by that, 0.4. 9 times 0.25. How do we get?
2.25.
2.25, correct. 16 times 0.16. 16 times 0.15.
2.4.
24, 25 times 0.3.
7.5.
So let's sum them up here to get the summation of x squared px. 0.2 plus 0.4 plus 0.25 plus 2.4 plus 7.5. What do we get?
12.75.
Good. Is this a variance? The 12.75, is that a variance? Ladies, is that the variance? No, it's not a variance. But what is a variance?
Wait.
The difference from the mean.
Sorry, the difference from the mean, yeah.
So 12.75 minus what? 3.25 squared. Isn't it?
Yeah.
So this would be 4.75 minus what? 10.56. So what you're going to get to be 2.19. Or to be specific, the whole figure is 2.1875. Then how do we find our standard deviation? How do you find the standard deviation?
Square root the variance.
Good, we square root the variance. So what answer do we get when you square root the variance here? What do we get
3.571.
3 point. Let's show square root.
571.
People confuse square root and the square. It should be smaller than this. 1 point something.
1.479.
1.479. All right.
Okay, I did the square root of 12, so 12.75 instead of 2.1.
Then how do you find the probability of x greater or equal to 3? Which values are we looking at?
Three, 4, and 5.
3 itself, 4, and 5. So when we add these ones here, what are we getting? .7. Okay. So when we add all these, we get 0.7. This is how we use our discrete random variables. Discrete random variables. Okay, so we'll look at another probability distribution, which is called the binomial distribution. Binomial distribution. That is our next session.